Right, so in this video I'm going to have a look at some more complex numbers, and I'm going to have a look at polynomials. So first of all, I'm just going to have a look at just a definition or two. So let's have a look at this polynomial here, or this function here, f of x is equal to 3x to the power of 5 plus 2x to the power of 4 plus 3x minus 4. Now what we would say about this is that this here has a degree of 5. And what that means is that the highest power of x is 5. We've got an x to the power of 1, an x to the power of 4, and an x to the power of 5. So the highest power of x is 5, so the degree of this here is 5. Now, that means that f of x is equal to 0. If we let this equal to 0, we will get 5 solutions. Now, if it was of degree 4, for example, we would get 4 solutions. We would get 4 solutions to x, f of x equal to 0, and so on. What I'm going to have a look at here then is the conjugate root theorem, and what that says is that if you have a complex number, z is equal to a plus bi, where a and b are real numbers, and a plus bi is one of the roots of some function f of x. F of x is a polynomial with real coefficients, which is important. So in other words, the numbers in front of the x to the power of 5s, x to the power of 4s, 3s, 2s, 1s, and so on will be real numbers. These numbers here will be real. So a plus bi is one of the roots of some function f of x. Then the conjugate of that root is also a root. In other words, z conjugate is equal to a minus bi is also a root. So if you're given one of the roots of some function with real coefficients, and you're told that in this case, one of the roots is a plus bi, then a minus bi is also a root. We're going to use that in these questions. So I'm going to take an example here. F of z is equal to z squared plus 6z plus 25. This here is a quadratic function, and I'm going to say that one of the roots in this particular case is minus 3 minus 4i. So z squared plus 6z plus 25 is our polynomial, our function, and it's a quadratic polynomial. And I want to just verify first of all that minus 3 minus 4i is a root for this equation here. So in other words, z squared plus 6z plus 25 equal to 0. If I put this in here instead of z, I should get 0. So in other words, minus 3 minus 4i, we're going to square that, plus 6 times minus 3 minus 4i plus 25 should give me 0 when I work it out. So let's just do that and see what we end up with. Well, here we'll end up with minus 3 times minus 3 minus 4i, and then minus 4i times minus 3 minus 4i. Here we'll end up with plus times minus, minus 3 sixes, 18, plus times minus, minus 4 sixes, 24i, plus 25 equal to 0. Let's just multiply this out then. We get minus 3 by minus 3, 3 3 is 9, minus times minus plus, 3 4 is 12i, minus times minus plus, 3 4 is 12i, minus times minus plus, 4 4 is 16i squared, minus 18 minus 24i plus 25 equal to 0. So let's just do these then. So we have 9 minus 18. Okay, we'll do the numbers first. Okay, so 9 minus 18 will give me minus 9. Minus 9 plus 25 will give me 16. Now, I also have a plus 12i, which will give me plus 24i, and I have a minus 24i here, and I also have this plus 16i squared here. So let's just finish that off then. I can see here that this 24i minus 24i will just give me 0. And here I end up with 16. Now, I squared again, I squared is equal to minus 1. So instead of this I squared here, I can just stick in minus 1. Minus 1 times 16 is minus 16. And I just get 0 equal to 0. So that's correct anyway. So this here, this particular root here is a root of this particular function here, f of z, z squared plus 6x plus 25. So we know that this function here, it is a polynomial function, it has real coefficients, we have one of the roots, so that would just simply mean that we have the other root as well. So another root must be minus 3 plus 4i. That's the conjugate root theorem. If we have one, it is a root, it's a root of a polynomial function with real coefficients, then the other root is minus 3 plus 4i. So we have two roots in this case. Okay, so let's just move that up again and let's have a look at another one. Let's say we take z, I'll just do this in white here, let's start again. So let's say we have z cubed and minus 5z squared plus 4z and plus 10, and that's equal to 0. Okay, so z cubed minus 5z squared plus 4z plus 10 equal to 0. Yeah, that's fine. So we're going to take z equal to minus 1, okay, as one of our roots. Okay, z is equal to minus 1 is one of our roots. So let's just verify that first of all. So that would mean that minus 1 cubed minus 5 times minus 1 squared plus 4 times minus 1 plus 10 should give us 0. So let's see, does that work? Minus 1 cubed is just minus 1. Minus 1 squared here is plus 1. We just end up with minus 5 there. Plus 4 times minus 1 is minus 4. Plus 10 equal to 0. So we end up with minus 1 minus 5 is minus 6. Minus 4 is minus 10. Plus 10, that does give us 0. So we just end up with 0 equal to 0. So that's fine. This here is one of our roots of this particular function here. Now, what we're going to do here is just show, remember this is a function of degree 3, so it has 3 solutions. We only have one of our solutions, and one of our solutions is z is equal to minus 1. There are 2 more, and we have to find those. So we're going to find the other 2 roots of this function here, and we're going to actually find that they're complex roots. Now, how are we going to do that? Well, if z is equal to minus 1 is one of our roots, that means that z plus 1 is a factor. This should be a factor. So that should be a factor of this particular function here. So I'm going to divide this in here, which will give me a quadratic function. I'm going to solve that quadratic function to give me the other 2 roots. So I'm going to divide z plus 1 into this function here. So let's do that. So I have, let me just write it down first before I move that up. Let's see, we got, whoops, let me just move that over and drop that out. Start again. So let's see, what is it? Z, we've got z cubed minus 5z squared plus 4z plus 10. And what I'm going to do is divide into that z plus 1. Okay, so let's see what happens when we do that. Now z into z cubed is z squared. Multiply z squared by these 2 here, and we get z cubed plus z squared. So what I do next then is I just subtract that, and I should get, well, this will just give me 0. Minus times plus is minus, so I have minus 5z squared minus 1z squared. That'll give me minus 6z squared. So I'm just going to take this here, I'm going to bring it down, and that'll give me plus 4z. So start again then. Z into minus 6z squared gives me minus 6z. So now multiply this by this, write my answer down here, same thing again. Minus times plus is minus 6z squared. Minus times plus is minus 6z times 1 is just 6z. Let's do the same again. Put a bracket around this and I'm going to subtract it again. So let me see, minus times minus plus, this will just cancel here, I'll get 0. This will become minus times minus is plus, so plus 6z plus 4z will give me 10z. Take this 10 here, bring it down, and I end up with plus 10. Z into 10z is plus 10. Multiply now 10 by all of this, so 10z plus 10. When I subtract that, I will just get 0, 0. Okay, so z plus 1 is a factor of this. Well, we knew that anyway, and when we divided it in, we got z squared minus 6z plus 10. So in other words, if I multiply z plus 1 by z squared minus 6z plus 10, I will get all of this here. Now, I'm going to use this quadratic to find the other two roots of this particular function here. So I'll just write it down here. It's z squared minus 6z plus 10. Now, I know that this must be equal to 0. So what I need to do is factorize this. If I try and factorize it, I know it's not going to work. I know I'm not going to be able to do it. So I'm going to use the formula to work this out. So I know that a is equal to 1 here, b is equal to minus 6, and c is equal to 10. So I know that z is going to be equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. So let's just stick these in and see what we get. Minus b then is going to be 6 plus or minus the square root of b squared, so it's minus 6 squared minus 4 times 1 times 10 over twice 1. Do I have that right? Let me see now. Minus 6 for a is 1, b is, or c rather, is 10, and then over 2a. Okay. So let's just work this out then. That's going to give me 6 plus or minus the square root of 6 is 36. Minus 4 times 1 is minus 4. Minus 4 times 10 is minus 40. And that's all over 2. That'll give me 6 plus or minus the square root of minus 4 all over 2. Now, I'm just going to split this up again. I'll do it over here. So that means then z must be equal to 6 plus the square root of minus 4 over 2, or 6 minus the square root of minus 4 over 2. So when I do that, then I get z is equal to, now this here will give me 6 plus, I can say that's minus 1 times 4. I'll do this out in detail. You should be able to really do this in your head at this stage, but I'll just do it out in detail first. So it's 6 minus 1 times 4 here as well over 2. So that will just give me z is equal to 6 plus, now square root of minus 1 is I, the square root of 4 is 2, so it's 2i all over 2, or 6 minus 2i over 2. When I divide the 2 in here into the 6 and the 2, I'll just get z is equal to 3 plus I, or in this case 2 into 6 is 3, 2 into 2 is 1, minus I. So these two here are my remaining two roots. Remember, I started off with a root of, I started off way up here with a root of this one here, root of minus 1. This is a real root, z is equal to minus 1. And by the time I got all the way down here again, I ended up with z is equal to 3 plus I and z is equal to 3 minus I as my two complex roots. There are 3 roots in total because we started with a cubic polynomial, so we needed 3 solutions. We've just worked out these two, and we started with z is equal to minus 1. And that's it for this video.